Today I am going to talk about Indian plate movement and the formation of Himalayas in continuation of the last class on continental drift. In the last class, we discussed about the continental drift hypothesis, which was proposed by Alfred Wegener, and also its research, exploration and expedition to collect the evidence to prove the continental drift hypothesis. According to him, Pangaea was a supercontinent. Later it split into two, Eurasia and Gondwana. In today's class, we are going to talk about the one among the plate tectonic piece which was splitted or drifted from Gondwanian land, which is Indian plate. The Gondwanian land split into five, such as Africa, South America, Australia, India and Antarctica. India, about 90 million years ago, during late Cretaceous period, departed from Africa and traveled eastwards and collided with Eurasian plate around 50 million years ago. The journey of Indian plate on the Paleo-oceanic surface, which is Tethys Sea, was very interesting in world geography, especially when you look in the late Cretaceous. India was drifted from Africa and carried Madagascar and Seychelles along with, but on the way Madagascar and Seychelles left, then India was continued the travel eastwards. When you look at the Cretaceous tertiary boundary, the KT boundary, around 65 million years ago, the Indian plate was alone floating on the Tethys Sea. It was quite interesting, and also how one tectonic plate without any connection with the continental mass been survived and also undergone several geographical mutations. Around 50 million years ago, in the Eurasian period, the Indian plate arrived close to the Eurasian plate, but slowly it started colliding and subduction was accelerated there between Indian plate and Eurasian plate. In Miocene period, the process of the formation of Himalaya was accelerated. The collision between Indian plate and Eurasian plate was in peak. Then the present map, when you look at the orogeny of Himalayas, clearly indicates the sutures of these two plate, which is Indian plate and Eurasian plate. How the Himalaya, the formation in Himalaya, changed the climatic conditions not only in Indian plate as well as in the entire Asia, which has changed the directionality of the global winds as well as changed the monsoonal pattern across Asia. What is subduction zones? When you look in the global map, there are several places the geographical process, the subduction, had been carried out. When you look at the left corner of this map, where you could find what kind of subduction was actually recent for the formation of Himalaya. When you look at the yellow circles indicates the earthquake zones in this world, and the dentate, the red colored dentate indicates the subduction zones. So the Indian plate in fact undergone the subduction, the collision, and there is the overriding of the plates on one another. So that's the reason the formation in Himalaya was facilitated, and it is raised to the high altitude mountains in that particular region. This is how I would like to show closely that what exactly geographically and geologically the process occurred in the formation of Himalaya. The convergence plate movement, in fact, the overriding of the Indian plate with the Eurasian plate, then it's uplifted the Eurasian plate to raise up the high altitudinal Himalayas. So the orogeny, it's like subduction orogeny. When you look at the topography of mountains, it is multi-layered. The significance of the collision, the two plates, when it was collided, it is changed not only the physical features of the world and also biologically. So I am just going to give some of the snapshots of the biogeographical process, what actually changed or facilitated the biodiversity in the particular region. So Indian plate in fact carried some of the biotic forms. What does it mean? The vegetation as well as the animals which is depend on those vegetation. When it was drifted from Africa, it carried those biotic forms from Africa, and it was orphaned in the midst of the Tethys Sea for about 60 million. So this geographical mutation was occurred. It was away from on all the sides. There is an oceanic barrier. The India plate was in fact it's without any contact with the mainland main landmass, but it traveled and reached the Eurasian plate. So there is exchange of biotic forms, biological organisms in the form of animals, in the form of vegetation, in the form of microbiota, and any soil microorganisms which were very poor in dispersal have been carried from Africa to Eurasia. So based upon this particular event, there is the exchange of biotic forms from Indian plate to the Eurasian plate, as well as the Indian plate received the biotic forms from Eurasia, contributing some of them the original forms from Africa to Eurasia, as well as the receiving the forms from Eurasia to India. Through India, it has also been reached Africa. So that's why in biogeography, the Indian plate is called biotic ferry, because it acted as a ferry to carry the biotic forms from one continent to the another continent in geological time. So the orogeny of Himalaya, we know very well that the monsoonal pattern as well as the global winds which been redirected because of the highest altitudinal orogeny which is present in Himalaya. So when you are talking about Himalaya, the age it's about 22 million years ago. The complete Himalayan formation ended up around 22 million years ago, but the start of Himalayan formation is started about 55 million years ago. But we also look at there are several other mountainous range in India, especially in the peninsular India. The west coast is guarded by the Western Ghats. The east coast is guarded by the Eastern Ghats. There are several other mountainous range in the central India, which is Vindhya Satpura range, as well as in the western, close to Thar Desert, we have got Aravalli range. So orogeny of Himalaya, it's significant with respect to the Indian biogeography. After the formation, the complete formation of Himalaya changed the tropical zone into the temperate. It departed from Africa but collided with Eurasia, and due to the elevational gradient, it has been uplifted to the higher altitude, it changed the climatic conditions. And also, when it was collided with Eurasian plate, the convergent, due to the process of the convergent plate moment, it is also carried the Tethys Ocean to that high altitude. That's why what you see today is a crystalline, multi-layered, and highly imbricated mountainous range at the top of Himalaya, where you will find lot of fossil records which evident that the presence of the Tethys Sea at the highest peak of Himalayas. The paleoclimatic conditions also contribute some of the evidences with respect to the presence of the climatic conditions. The green, I would like to just show you the green dots. The green dots indicates the coal beds, the present coal beds distribution in the world. The coal distribution that indicates the presence of the rainforest in the ancient continental mass. But in this particular map, you could only see the Miocene period, but we are not very sure that at what period the rainforest had been buried into soil, then had been converted into coal beds. All this vegetation, the rainforest vegetation, been buried in the swampy lands, then it will become the coal beds. We know there are several records to indicate that that belongs to the Carboniferous period, but even simultaneously they indicate the past or paleoclimatic presence of the tropical or rainforest regions. When we look at the different tectonic plates in India, I would like to show there are some of the intracontinental shelves also occurred. When you look at in India, the very important and also the age-old geographical process that is the Deccan Intertropian region. Along with there are several cratons that we couldn't see because it's there in the continental crust, but these cratons plays a major role to shape the physiological features of India. Aravalli craton, Bandalgan craton, Singhbum craton, Bastar craton, Dharwar craton, also the southernmost granulate zone. When you actually overlay the mineral deposits which has been mined from India, probably it would easily correlate with these particular cratons. Take example the granulate from Tamil Nadu. There are the marble mines occurred. When you go towards Andhra Pradesh, there are Kadapa stones. Also, is the type of granite stones being mined. So these are all belongs to the craton, which is based on the granulate stones, rocks. Dharwar, again the Dharwar craton, where you will find the Bellary mining zone, and Bastar, especially the Singhbum, the Tata Steel Industries, Jamshedpur, all the mining zones are occurred. So these cratons, the intercontinental shelves, also represent that they carry the age in very old and in geological time. When you talk about the Deccan Intertropian zone, it is dated back to 400 million years ago. So it was present when the Indian plate was with the African plate. So it is not recently formed. This was the oldest geographic zone. So next, There are mountains, the physiographical features where we could look even in the map, that the mountainous range and plateaus. As I mentioned in the earlier slides, the west been guarded with Western Ghats, the east is guarded by the Eastern Ghats. The central India, we have got Vindhya Chatpura range, and also we have got the plateaus, Deccan plateau. So these zones and regions also it is an intact part of the Indian plate, and they undergone several geographical process in the journey of the Indian plate from Africa to Eurasia. Just I wanted to give the special address to the Deccan Trap. Deccan Trap is one of the largest volcanic feature on Earth, because it is one of the largest spread, and they dated back several million years ago. And importantly, the formation of the Deccan Trap, it is multi-layered. We form especially in the northern part of Western Ghats. When you look at, probably in the forthcoming slides I would like to show, you could easily see in the Ajanta caves, and also the satellite image of the Deccan Traps found in Maharashtra, which beautifully it shows the tabletop mountains. That's why it is called the Deccan Trapian region. It's called, especially the state Maharashtra, it's called the igneous province of India. I would like to show some of the pictures. This picture is taken by me from Thakarwadi, shows the beautiful orogeny assemblage of the basalt rocks that indicates the Deccan Intereuropean region. The another one is the limestone caves of Western Ghats. Again, limestone caves carries a very good geological history. Some of the carbonic acid rich water that eroded the limestone mountainous range that formed into the caves. This particular caves found in Yana, in the central Western Ghats of Karnataka, where you will find the limestone caves. The limestone caves are dated back in geological time, and these striations, of these mountainous peaks indicates that Indian plate would have submerged into sea when it was traveling eastward to Eurasia. So there are the process and the event of submerging into sea and coming up from the sea and floating and submerging, probably in a cyclic manner. So wherever it is possible for the mountainous range to get eroded, those striations has been observed in this particular zone. This is one among the examples to show that the Indian plate probably have submerged and then emerged back, and then that's how the journey took over to reach Eurasia. The beautiful Western Ghats peaks carries the shola vegetation. The feature of the shola vegetation, we know very well that the richness of the minerals that favors the vegetation only in the valleys, not at the mountainous peaks. And another panoramic view of Agasthyamala, which is southernmost part of Western Ghats. It's example for the richest plant diversity as well as the endemic fauna. This is the southernmost tip of Western Ghats, where the Western Ghats end at Kanyakumari. The another panoramic view of Palkonda Hills of Eastern Ghats, situated in Andhra Pradesh. This particular mountain is dated back about to Cambrian period. which is not very close. It's a Cambrian period, where that period, the Pangaea, even the Pangean continental mass was not there. So it was intact, the Indian plate, especially the peninsular India, it was very old in geological time. That's why that's a point which I wanted to make here. When you compare the age of Himalaya, the age of Western Ghats as well as the Eastern Ghats is much more older than the Himalaya. The another one is the volcanic islands of Andamans. The Andamans, especially when still there are live volcanoes exist in Andamans. The one example is the mud volcanoes present in Barren Island. So that indicates that most of the islets of Andaman and Nicobar Island are the volcanic islands. It is not the continental highlands. It has probably been emerged out of the volcanic eruption. So there, I'll probably complete this talk related to the tectonic movement of Indian plate as well as the formation of Himalaya, and also discussing about the intracontinental shelves of peninsular India. Thank you for watching. Kindly share and subscribe.